In this topic, we are going to cover inheritance. Inheritance is a way of creating a new class by using details of an already existing class, but without needing to make any changes to that existing class. So if classes are similar or have similar functions, you don't need to copy and paste or recreate entirely new code and functions. You can instead derive them from an existing class. When using inheritance, the new class is usually referred to as a derived or a child class, while the existing class is referred to as the base or parent class. So to start, let's first copy and paste the person class from the previous lesson, and this will be our parent class. Control C, Control V, let's save this. Inheritance.py. And now that we have our parent class, we can also create our child class. So let's create another class here called hacker. And this hacker child class takes the base class to inherit after the class name. So in this case, person. And let's create an initialization function for this hacker class. Self name age, just like our person class. But let's also include CVEs here. Next, since we are a child class, we want to call super.init name age. And super here lets us refer to the base class without explicitly referencing it. And now we can create the CVEs attribute. And let's also create a function, print name, because for the hacker class, we want to have a modified version of the print name function to also include our CVEs. So we could say, my name is, and I have CVEs, dot format, self.name, self.cves. And we might want to add another function, total CVEs, and we can return the number of CVEs that we have. So now that we have our classes, let's instantiate some instances of them. So let's create Bob, and Bob is going to be a person, Bob, and he's 30 again. Also create Alice. However, Alice is a hacker. She's 20, and she has 5 CVEs. And now we can call the print name functions, print name for Bob and print name for Alice. And we can execute this. And here we can see the different output for calling the exact same function name. So bob.printName says my name is Bob, whilst alice.printName says my name is Alice and I have 5 CVEs. And we can also access variables and functions from the child class, which also still exist in the parent class. So to demonstrate this, we could print out bob.age and also alice.age. We can also call the birthday function, bob.birthday, alice.birthday. And let's print out their ages again after calling that function. Just copy and paste. And here we can see that for Alice, even though we have no function defined here called birthday, we still have access to the birthday function in the parent person class. However, we can only access variables and functions in the child class for instances of that child class. So for example, we can say print alice.total CVEs. And we can see we get 5 here because Alice has 5 total CVEs. However, if we try to do this for Bob, we receive an attribute error because the person object has no attribute total CVEs. And if you aren't sure whether your object is a parent or a child, there are functions which exist to show you that relationship between classes. So for example, we could print is subclass hacker person. We could also print is subclass person hacker. And this function returns true if the given class is a subclass of the parent class. Let's comment this out. And here we can see that hacker is a subclass of person. However, person isn't a subclass of hacker. And we can also use is instance Bob person is instance Bob hacker. And the is instance function returns true if the object is an instance of the class or if it's an instance of a subclass. So we can execute this and we can see that Bob is an instance of person. However, Bob isn't an instance of hacker. And we can also look at this information for Alice. And we can see that Alice is an instance of person and Alice is also an instance of hacker. And as we've seen, inheritance is another powerful object-oriented programming idea which enables us to reuse code and create even more modular classes. Rather than rewriting and copy and pasting code, we can instead build upon existing functionality. But that's it for now, and in the next lesson, we are going to cover encapsulation.